Hey, today we are going to talk about special products of binomials. So we're on pages 21 and 22 in our notes. So there are a bunch of patterns that exist when certain types of binomials are multiplied. So in the space below, describe why it would be helpful or important to recognize mathematical patterns. So I think of patterns as just maybe doing it a little bit faster and quicker. Okay. So what we're basically going to do is look for patterns today and see if we can use any of those. Now, I'm not a big, when it comes to algebra, I don't love patterns and like using tricks and stuff. But if you do like them and you would prefer to use them, you can. I always like them old school and I will always just do it the way I know how to do it. So first, what we're going to do is we're going to observe a pattern that occurs when a binomial is squared, or if it's multiplied by itself. So the first thing I have to say is when we are squaring things, I'm going to say write it out. Okay, again, I don't love patterns because we think we can do it really quickly and easily, but we have to know, like for this problem, x plus 1 is being squared, which means I'm writing x plus 1 out 2 times. Okay, this binomial is being multiplied by itself 2 times. That's what the square means. Okay, so for this one, it would be x minus 6 squared, so I'd write it out twice. X plus 5 squared, and 2x minus 3 squared. Okay. People usually miss these problems because they're trying to use the pattern, or they're trying to just do it so quickly they forget parts of it. So my suggestion is to always write it out. Okay, now we're just going to multiply how we know how to multiply. So we're going to do x times x, which is x squared. X times 1, 1x. Now we're going to multiply the 1 times x, and the 1 times 1, which is 1. Okay, so simplified, this is x squared plus 2x's plus 1. Okay, for the next one, we're going to do x times x times negative 6. Now we have negative 6 times x, and negative 6 times negative 6. Okay. So simplified, we have x squared minus 12x plus 36. Right, the next one, x times x times 5. Now we have 5 times x and 5 times 5. So simplified, we have x squared plus 10x plus 25. All right, for the last one, 2x times 2x would be 4x squared. 2x times negative 3 would be negative 6x, excuse me. Now we're going to do negative 3 times 2x and negative 3 times negative 3. So simplified, that would be 4x squared. Negative 6 and negative 6 would make negative 12, so negative 12x plus 9. Okay, so first, just looking at the patterns, if we notice anything about the original squared binomial, so we're talking about this right here, okay, and our final result, okay. So we have 3 terms in all of our math problems. So we're basically just seeing if we can notice how we can get those things, okay. So I notice that this number or this term is always the square of the first thing, because the very first thing we do is x times x, x times x, x times x, and then 2x times 2x, which would be the 4x squared. So it looks like the first term would be the first, I don't even know how to write it, the first part of the first term squared. Okay. The last term, so which is like the 1, the 36, the 25, and the 9. If we look at the original problems, it looks like we're getting that when we're doing the 1 times the 1, the negative 6 times the negative 6, 5 and 5, and negative 3 and negative 3. So it looks like it is the last term in the problem, or last part, squared. Okay? So the last thing we do is we multiply the last term times the last term. They are the same exact thing since we're squaring it, so we could just square it. Then the hardest part is figuring out this middle term, okay? So the 2x, the negative 12x, the 10x, and the negative 12x, okay? So what I noticed every time we were doing this multiplying is I would write this twice because I would have to do x times 1 and then 1 times x times negative 6 times x. All of these were always the same thing. These were the same thing, and these were the same thing, okay? How we got those numbers was we had to take the two terms, okay? We had to multiply the two terms. Okay? And because we wrote it twice, we then had to double it. Okay. Now, me personally, I will always just write it out and do it the way I know how to do it, but there are patterns to all of these things. So what we're going to do is we're going to create a graphic organizer for each example below. So the square of a sum and the square of a difference. And then we'll use our graphic organizer to basically summarize what happens. So if we have a square of a sum, so a square means we're squaring something, sum means we're adding two things together. So we're going to make a graphic organizer like we had before, just this one time to kind of see the patterns. So that means we would have A and B, A plus B, times itself twice. So I'm going to write A plus B again. Okay. I'm also just going to write this squaring a sum means we are taking the same exact thing and multiplying by itself twice. Okay. So now let's just multiply A times A, which is A squared, A times B, which is AB, and then B times A, which is AB. I like to put alphabetical, and then B times B, which is B squared. Okay, so overall, we have A squared. Okay, I notice that we have two of the same thing, so we have two ABs, and we have B squared right here. Okay. All right, the square of a difference, which means we're taking two terms and we're subtracting and squaring it. So literally what that means is we're taking A minus B times A minus B 2 times. So we'll have A and negative B times A and negative B. All right, now we're going to multiply. A times A is A squared. Okay. A times negative B, I'm just going to write negative AB. Okay. Negative B times A, again, I'm going to put it alphabetical. And then negative B times negative B would actually become a positive B squared. Okay. Then if we combine like terms, we have 1A squared. We have two of the same things. We have negative 2AB, and then we have 1B squared. Okay. So trinomials written in the forms above are called perfect square trinomials. Okay. Because they're the same thing, it would be a perfect square. So if you guys are interested in using these rules, you can definitely use these rules. You can notice that we are basically going to square the first term. We're going to square the last term. We're going to multiply the two terms together and double it. Okay, so I'm going to do a couple the way I would do it. Okay, so I'm just going to do this one. I'm going to take the extra second. I'm going to write it out. Okay, and then I'm just going to multiply x times x squared, x times 9, 9x. Then we have to multiply this. We have another 9x. And then we have 9 times 9, which is 81. Okay, so what this form is telling us is basically we could just square the first term. So I do see an x squared. Okay, I see two 9x's, which means I take these two terms and I multiply them together. X times 9 is 9x, and I would have two of them if I multiply them out. So that would create a total of 18x's. And then b squared would be taking this term right here and squaring it. We also get that when we do 9 times 9, which is 81. So I want you guys to try a second. Again, I prefer just writing it out and doing the multiplication that I know how to do, but you guys can use the trick or you guys can just write it out. So go ahead and try it. Okay, so for this one, if you wrote it out, it would be x minus 7 and x minus 7. Okay, and when you multiply it out and combine like terms, you should square the x times x. Okay, you would do x times negative 7 and another negative 7 times x. Okay, or you can multiply these together and get negative 7x and double it. Either way, you should get negative 14x. And then the very last thing is we will multiply negative 7 times negative 7, or we will square our last term and get positive 49. Okay. For the next one, again, I'm going to write it out. Okay, we would get m squared. Okay, we would get negative mn. We would get another negative mn. Can I put them in alphabetical order? So that means I have two of them and they're both negative. So that'd be negative 2mn. Okay. Then finally, I could square the last thing. Negative n would create a positive n squared. All right. And for the final one, 4x plus 2 squared. Okay. So we could square 4x squared, which would be 4x times 4x, which would create 16x squared. Okay. Then we could multiply these together and get 8x and double that. Or you could do it the way you know how to do it. 4x times 2, which would be 8x. 2 times 4x, which would be another 8x. Lo and behold, no matter what, you should still get 16x. And then the final thing is you could square the last term or just multiply it out and do 2 times 2, which is 4. Okay. All right, final question for on the front page is write an expression for the area of a square. So I'm going to draw a little square with a side length of 3x minus 10. Okay, well, we know that area is length times width. Okay, and we also know that squares mean they have the same length for every side. So an expression we could write would be 3x minus 10 times itself twice. So we could write it as a square. Okay, we could also simplify this because if we have exponents, we should hopefully simplify this and get rid of the parentheses. Okay, so we could do 3x times 3x, which would be 9x squared. Okay, we could do 3x times negative 10, which is negative 30x. Then we would do negative 10 times 3x, which is another negative 30x, okay, which would make a total of negative 60x. Okay, again, the shortcut is multiply these two together and then double it because we would have 2 when we multiply. And then finally, we would do negative 10 times negative 10, which is 100. Again, the shortcut would be just to square the last term. Okay. So both of these are technically correct. We usually like to simplify, so this is our correct answer, 9x squared minus 60x plus 100. All right, off to the next page, which is page 22. So we're going to look for another type of pattern. So these problems, we are just going to do it the way we know how to do it. There's another pattern that exists when we multiply a sum and a difference, which means this is the same problem, but as a sum, as this problem is a difference. So same problem, same numbers, same terms, just one's adding, one's subtracting, one's adding, one's subtracting, and one's adding and one's subtracting. So we're going to multiply the way we know how to multiply and then hopefully see if we have any patterns. Okay, so we're going to do x times x. We're going to do x times negative 3. Right. Now we're going to do 3 times x and 3 times negative 3. Okay, when I simplify, I have x squared. I'm going to put those together. That makes a 0, so I don't need to write anything. And then I have minus 9. All right, next one, x times x times 5, negative 5 times x, and negative 5 times positive 5. Okay, simplified, x squared. That makes a 0x, so we don't need to write anything. minus 25. Okay. If you see the pattern, you could try these problems without doing it all the way through. Okay. 3x times 3x, well, 3 times 3 is 9, and then x times x is x squared. Okay. 3x times 2 is 6x. Now negative 2 times 3x is negative 6x, and negative 2 times positive 2 is negative 4. Okay. So when we simplify, we have 9x squared. I see a 6x and a negative 6x, which would make a 0, and we would be left with negative 4. Okay. For the final problem, we have 4x and 4x, which would make 16x squared. 4x times negative 6, 6 times 4x, which would be 24x, and 6 times negative 6, which would be negative 36. All right, we would have 16x squared. When we combine these, we would get a 0, and we would get minus 36. Okay. Compare the products above to the original binomials when being multiplied. Describe what happens when multiplying a sum and a difference. Okay. Well, I definitely noticed that when we multiply a sum times the same thing as a subtraction problem, the middle terms cancel out. So we would have no x term. Okay. Something else that I noticed is that when I multiply x times x, I get x squared, and then I'm left with 3 times 3, which is a perfect square of 9. So let's just see if that works for all of them. X squared, 5, 25. 3x and 3x, that is also a perfect square. 3 times 3 is 9, and then x squared. And then negative 2 and positive 2, which make that perfect square of 4. Then 4x and 4x, also a perfect square, 16x squared, 6 and negative 6, which would make a negative 36. Okay, so this is called the difference of two squares. So we have these squares, we have adding and we have subtracting. Okay, what happens is it results in the square of A minus the square of B. Okay. In other words, if we have two terms adding times the same two terms subtracting, we would do A times A, which means we are squaring the first term. Okay. Then when we multiply and multiply, that would make that 0 like we did in all these 4 examples. And then we would do B times negative B, which should be minus B squared. Okay. So this is when we have two terms, one adding, one subtracting. The trick is we could square the first one, the middle stuff would cancel out, and we would subtract because one's subtracting, one's adding, the B squared. This form, A squared minus B squared, is known as the difference of two squares. Difference, and we have two squares. Okay, again, I'm not a lover. I don't love tricks, but these do definitely work if you like to do it. Okay, me personally, I'm going to just keep doing it the way I know how to do it because I feel 100% confident with that. So I'm going to do x times x. Okay, I'm going to do x times negative 8. I'm going to do 8x. And then do 8 times negative 8. Okay, and then I just happen to notice that those make a 0, and we're left with x squared minus 64. All right. Again, you can use the trick. I notice that they're the same thing. One's adding, one's subtracting. The trick is to take the first term and square it. Okay. Knowing that they would cancel out, then I would do n times negative n. And that would be it simplified. All right. For this one, again, if you want to use the trick, you would do 6x times 6x, or you would square it, and you would get 36x squared. Okay. Knowing that one would be a subtraction and one would be adding, that would make a 0. So then all you're left with is multiplying 7 and negative 7, which is also a perfect square, which is minus 49. Okay. Maya needs to solve 4x plus 8 times 4x plus 8. Jude says that she needs to square the first term, 4x, and subtract the square of 8. Is Jack correct? Explain why or why not. Okay. Well, I'm just going to do the problem I know how to do. So I'm going to do 4x times 4x, which is 16x squared. Okay. 4x times 8. Okay. Then I'm going to do 8 times 4x and 8 times 8. Okay. So simplified, I would get 16x squared. These do not cancel out. These add to it because we have two adding problems. So that's 64x plus 64. Okay, so Jude says that you can square the first term, 4x, so 4x times 4x, which is 16x squared, which we do have, and then subtract the square of 8. 8 times 8, which is 64, and subtract it. So it looks like Jude is not right, and that's because she forgot the negative or the plus 64x. When I look at this problem, this does not look like the difference of two squares like these problems. This looks more like the front page where we have the square of a sum. We're taking the same thing and we're multiplying by itself twice. So no, Jude is not correct. This is actually the square of a sum. Okay. Give an example of two binomials whose product will result in the difference of two squares. So again, difference of two squares is a squared minus b squared. So it's asking us to create something that would look something like this. Okay. So we could come up with literally millions of ideas. We could do x plus 4, and then it would be x minus 4. Okay. We could check it to make sure we get it right. We would do x times x times negative 4, 4 times x, and 4 times negative 4. These would make a 0, and we would be left with the difference of two squares. Okay. Again, I don't love patterns, so if you like the patterns, cool. I'm just the kind of person that's just going to do it the way I know how to do it and how I feel confident with it. So apply the patterns of special products to match each expression on the left with its product on the right. Notice, no, not all choices will be used. Okay, so again, you can use your pattern, or you could just write it out twice and multiply. Okay, this would be x squared, negative 8x, another negative 8x, and negative 8 and negative 8 make positive 64. So this would make negative 16x and a positive 64. So it looks like D is our correct answer. Okay, again, you could use subtract a difference of squares. Okay, x squared, you would double it after you multiply and get negative 16, and then you would square the last one. Okay. The next one, this is the difference of squares, if you notice that. Okay, again, I'm just going to do it the way I know how to do it. X squared minus 6x plus 6x minus 36. Okay, I combine those, that would make a 0. And so E is our correct answer. Okay, for this one, again, we have two, the same thing, just one adding, one subtracting. So this will be difference of squares. Again, I'm just going to do it the way I know how to do it. 4x squared, 2x times 2x, 2x times 5, negative 5 times 2x, and then negative 5 and negative, or positive 5. Okay. This would make a 0, and I'm left with 4x squared minus 25, which would be h. Okay. 3x plus 1 squared. Again, I'm going to write it out and then just do it. 3x and 3x, 3x and 1, 1 and 3x, and 1 and 1. Okay. These would double and make 6, so I'm looking for 9x squared plus 6x plus 1. All right, and then finally, x plus 4 times x plus 4, x times x, x times 4, 4 times x, and 4 times 4. That would combine to 8x. So F looks like that is the correct answer. Okay. Again, when you guys get older, you probably, because you're going to be doing these for many years, you probably will get the tricks eventually. If you get the tricks now, that's awesome, but I wouldn't rush it. I would make sure that you understand how to multiply and then maybe look for patterns afterwards.